Hello class. Okay, in this video we're going to go over the first exponent rules assignment that we're going to do together. Okay, so in class we will actually work this one together. So those of you that are Model C, just kind of go through this as I go through this, because the next assignment that I give you, you'll be doing the same exact thing, but it'll be for a grade. So here we go. In questions 1 through 6, it says rewrite the following with positive exponents. So if you remember correctly, the negative exponent, what it was, is a flipper. That's what we talked about in that exponent lab. So if I want you to rewrite this with a positive exponent, number 1 is going to be 1 over 7 to the 5th power. Okay, number 2, okay, since this one is in the denominator, this one's going to flip it to the numerator. Like in the last one, if you write it as a fraction, the 7 to the negative 5 is in the numerator, so the negative flips it to the bottom. Okay, so this one flips it to the top, so it's just going to be 3 to the 2nd power. Number 3, it's in the numerator, so it's going to flip it to the denominator with a positive exponent. Number 4, the same thing as number 3. This one's in the numerator, so it's going to flip it to the denominator with a positive exponent. And it works the same even if you have variables. So this one, it's in the numerator, so you flip it to the denominator. Okay, also works even if you have a negative base. It's perfectly fine. This one is in the numerator, so it's going to flip it to the denominator. Now, since my base is negative, it has to stay negative, but my exponent turns positive. Okay. In the second one, I'd like for you to write it with a negative exponent. Now, this will be the only time I allow you to actually write something with a negative exponent, because we're just practicing that property. Okay, any other time, you must write your answers with a positive exponent expression. Okay, so on number 7, if it's positive in the denominator, that means it's going to be negative in the numerator. Positive in the numerator means it'll be negative in the denominator. Same thing for this one. So this one becomes 1 over 2 to the negative 5. Number 10, it's in the denominator, it's positive, so that means in the numerator it'll be negative. Okay, this one is positive in the numerator, so that means it's going to be negative in the denominator. But my base still stays negative no matter what. It's the exponent that's going to turn negative. And if you have a variable, same thing. P to the 9th, positive in the numerator, it's going to be negative in the denominator. Now, 13 through 18, I want you to evaluate each of these. In other words, come up with an answer. Now, in all of these, we're looking for an exponent of 0 and an exponent of 1. We know that anytime it has an exponent of 0, your answer is 1, no matter what it is. So 13 is 1, 15 is 1, 17 is 1, 18 is 1. No matter what is in that z or what is in that p, if it's to the 0th, your answer is going to be 1. Now, if you have an exponent of 1, you just get back whatever it is that was the base. Okay. So now, in this one, it says rewrite each problem with a 1 exponent expression. And it must be a positive 1 exponent expression. So it says if the exponent is negative, rewrite with a positive exponent. So all we're doing is rewriting each of these. We're not evaluating them. We're just rewriting them with exponents. So number 19 should be 2 to the 3rd power. You've got 3 2's, so 2 to the 3rd. Okay, on number 20, our bases are alike, so we add our exponents. So 3 to the 7th. Number 21, we have a base raised to an exponent raised to an exponent. So if you remember the property, you multiply the exponents together. So this becomes 6 to the negative 8, which will then turn into 1 over 6 to the 8, because I need it as a positive exponent. Number 22, our bases are alike. Our exponents are different, so we add the exponents. So a to the 6th. Number 23, our exponents are alike, but my bases are different. So in this one, we multiply our bases, and we keep our exponent. On number 24, we have a base with an exponent divided by the same base with another exponent. So if you remember, we subtract our exponents here, so this becomes 6 to the 2nd. Number 25 is like number 21. We have an exponent or base raised to an exponent raised to an exponent, so we keep the base and multiply the exponents. And number 26, there's actually 2 answers that you could put on this one. Okay, one of them would be 9 to the 1st, And the other one that would work would actually be 3 to the second. Either one of those would be an acceptable answer. Okay, number 27, your base is alike, so you add your exponents. So 4 to the 5th power. Number 28 is like number 25 and 21. You keep the base and multiply your exponents. Number 29 is like number 23. So you take your bases, you multiply them together, and you keep your exponent. Number 30. Okay, this one, it's a division problem like number 24. So we keep our base and we subtract our exponents. 3 take away 5 gives you -2. So that means you've got to rewrite this with positive exponent. So that becomes 1 over 2 to the 2nd power. Number 31, our bases are different and our exponents are alike. So that means we multiply our bases and we keep our exponent. But it's negative, so that means I've got to flip it. So 1 over 12 to the 5th. Number 32, okay, your bases are alike. So you keep your base and you subtract your exponents because it's division. So it's going to be a to the 1st power. Number 33, got 17 to the 8th and 17 to the 2nd, which is going to make 17 to the 10th. Okay, number 34, a bunch of those 8s there together. You end up with 8 to the 5th power. Number 35, your bases are alike, your exponents are different. So we add our exponents, so 10 to the -5th, which then turns into 1 over 10 to the 5th power. And number 36, it's just like 32. It's just we wrote it with this kind of division. Means the same thing. You still subtract your exponents. So you end up with 9 to the 5th power. Number 37, same thing that we just did on 36. It's just written the other way. This one becomes p to the -2nd, which then rewrites as 1 over p to the 2nd. Number 38 is a base raised to an exponent raised to another exponent. So we keep the base and multiply our exponents. So it's 4 to the 72nd. 39 just has a bunch of 7s. So we've got 1, 2, 3, 4, 5, 6, 7. So that would be 7 to the 7th power. And then last but not least, number 40, m to the 2nd to the 6th would be m to the 12th. So what you're going to do next is you're going to look at worksheet number 2. And I want you to complete that one just like we did in this particular one right here. These are some of the notes and examples that we will use to help us answer those questions. Okay, so until then, I'll talk to you later.